Hi, this is Les Hasbargen. This is a tutorial that shows you how to calculate the average precipitation using tools in Global Mapper. So you can see the list that we have here to work through. The goal is to calculate an area-weighted average precipitation given gauge locations and precipitation amount. So first we will start with a text file that has locations. So this is coordinate locations. This would be latitude, longitude, or in my case it's going to be a locally defined rectangular grid. So it has X and Y coordinates, and it has a precipitation value attached to each. It's a text file, and it also has a label for each station. So the steps within Global Mapper: you have to read the text file in, then you have to grid it, convert those isolated points, vector, into a grid data format. And this is the little summary of what you do: analysis, create elevation grid, ... Then you can create contours on that. Then the next steps for that are find area between the contours. There's a function for that. Then you have to export those measurements of the area of the polygons, area between contours, and copy that and paste it into a spreadsheet. The second method is to, instead of using contours and the area between contours, we use a Voronoi diagram. So this is a Thiessen polygon method. And so I'll show you how to do that. So let's go over to Global Mapper now. And here we are. So first we need to open up our data file. And let's see, where is this now? Oh, here we go. It's this one right here. No, not that one. This text file right here. And so I'll open that. And this is what you should see, point only. We don't need to skip any data at the start of the file, nor do we need to skip our first line. Notice that if I did tell it to skip the first one, it would start at B, so we'll say 0. Next, you can go ahead and, if it's set to comma, notice that you get garbage down here. We'll auto detect, and that looks like it's separated into proper columns. The attributes will include those, and that would be column 4. And the third coordinate, this one right here, is going to be treated as elevation. Now it's not really elevation, it's precipitation, but that's how we'll leave it. Next, we actually need to determine the projection system. And in this case, typically we'll start off with geographic, but we want equirectangular, and you can change the distance units for our data set. It's in kilometers, and the precipitation elevation is in meters. And then we'll say OK. Notice we have all of our points out here. So our first step then is to grid the data set. So we go up to Analysis, Create Elevation Grid, and we'll just leave the defaults here and say OK. And that's how you generate. You can see it's already in a color contour scheme here. This is the Atlas shader. If you did this daylight shader, you can't see much here. So let's go back to the Atlas shader. And now we need to generate contours. And so our contour interval, I'm just going to use 0.1, and might want to change the name here. And then I'll accept the rest here. And so there, my whole thing is contoured. And I'll pause